describe the different components of the anesthesia machine based on the molecular flow. So I'm going to start with our oxygen unit. This particular machine has the oxygen coming from the ceiling from our H tanks outside. The H tanks are the giant ones that are outside of the building and connected through a series of hoses throughout the hospital ceilings. And some machines are connected to E-tanks, which are the portable tanks. Those can be used for various purposes. A lot of times they're actually hooked up to the machines. So first we have where our oxygen is actually hooked in through this hose, through this valve right here. And then going through the machine, it actually connects to our flow meter. This here is our flow meter. Our flow meter, it actually tells us how much oxygen is going into the vaporizer. And the way that it works is you turn the knob and the ball almost looks like it floats upward, and you're able to read how much of oxygen flow the patient is getting based on where the ball sits. It's supposed to sit, the line is supposed to sit in the middle of the ball. So the line on the scale is supposed to sit in the middle of the ball, and that tells you how much oxygen your patient is getting. Next to the flow meter, we have our oxygen flush valve. This flush valve sends a rush of oxygen to the patient, bypassing the vaporizer. So it's just fresh oxygen that the patient is getting. The only time you would really use that is either in an emergency situation or if the patient needed just oxygen. So, okay, so next we have our vaporizing unit. This unit has a precision vaporizer. The oxygen actually flows into the canister along with where our liquid anesthetic is placed in. This unit evaporates that liquid into a gas, and it mixes with the flowing oxygen from the flow meter, and it makes our anesthetic mixture that our patient receives. This is called a precision unit because with this knob on top, we're able to control how much of that mixture our patient is getting at one time. So, okay. So it comes out through our vaporizer outlet, which is back here. It goes through a hose and it comes to our unidirectional inspiratory outlet, unidirectional inspiratory valve. It comes out. It comes out through a hose that's going down this way, and it meets up along this area. Our unidirectional inspiratory valve, we have the negative pressure safety valve. That's this valve here. If negative pressure ever occurs, then that valve is actually able to accept atmospheric air to stabilize the whole system. So after the negative pressure safety valve, we have the unidirectional inspiratory valve, which is delivering the gas and oxygen mixture to the patient, and it's sent via our coaxial Bain circuit. Coaxial just means that there's two valves in one. The inner tube is our inspiratory tube, and the outer tube is our expiratory tube. This kind of breathing circuit does have some thermal regulation properties. When air is expired, when breath is expired into the expiratory tube, it actually warms that incoming air, so it does have some thermal regulation properties. So above our breathing circuit, we have our flutter valves. There's an inspiratory flutter valve and an expiratory flutter valve. These flutter valves can be used, or primarily used to monitor respirations during anesthesia. especially if the patient is covered with a drape and you're unable to see the abdomen. These are good indicators that your patient is breathing. And next to these flutter valves, we have our pop-off valve. Our pop-off valve is also called a positive pressure releasing valve, and its function that is also partly safety. If excess pressure is present, then this pop-off valve allows that pressure to escape. This valve can also be used in conjunction with our reservoir bag. If we notice that the patient isn't able to take its own breaths, if we're in a procedure where we need to give the patient a breath, we actually close the valve, squeeze the bag, and then release. This valve always needs to stay open. If it stays closed for a period of time, then too much pressure can be experienced by our patient, and we can cause significant lung trauma or death. Our pressure is measured by our manometer. It's measured in units of centimeters of water. And we don't ever want that number to get above 20. A lot of systems actually have an alarm system that go off when it gets above 20. But generally someone should always be monitoring, someone should always be watching that, because we don't want that number to ever get above 20. So another function of the pop-off valve is that it allows that excess pressure to escape via our scavenging system. Our scavenging system is generally hooked up to another breathing circuit, and it is this canister down here, and it's filled with activated charcoal, which is able to absorb that waste anesthetic gas. Scavenging system can connect to our activated charcoal, or it can also go through the soda lime canister. The soda lime granules in the canister are able to absorb CO2 so that the rest of that air can be recycled and breathed again by the patient. These granules do need to be changed, generally every 8 hours of surgery. The granules will change, they will harden, or they will change color, but the best indication is just time of use as far as when to change them. So lastly, I did want to talk about our bag again. Its main use is to catch or trap any excess air throughout the system. And a lot of times when it comes into play, not only with helping your patient take a breath, but at the end of a procedure, usually when the procedure is being closed up, the ISO will be turned down to 0, and then we will squeeze with the remaining air left in this bag back into the patient, so that when we remove that bag, that excess waste or that excess gas doesn't go into the environment. I think I got everything. Okay.